Good day, learners. Today we are going to continue our solutions for May-June 2020, paper 21, and we are already in number 12. For number 12, this is the problem. I did not write any more the problem. So here, for number 12, we have Gemma records the times in seconds. So 20, 40, up to 100 seconds. Taken for a group of children, this one is for children, and a group of adults. We need to draw the box and whisker plot for the adults to complete a puzzle. So the adults and the children, they are going to complete a puzzle. So this one is for the children already. The box and whisker plot shows information about the time taken for the children to complete the puzzle. A. Find the interquartile range of the times taken for the children to complete the puzzle. And for letter B, we are going to draw the box and whisker plot for these adults. Okay. This is our box and whisker plot. The line here is for the minimum time. The other vertical line here is for the maximum time. Okay. This line here, inside the box here, we have a box here. This line inside the box is the median. This side of the rectangle to the left is the lower quartile, and the side of the rectangle on the right side here, this one is the upper quartile. The interquartile range is equal to the distance, this distance here. So the interquartile range is equal to the upper quartile minus the lower quartile. Okay. So here we know that the median is 62. The upper quartile is 70. The lower quartile is 48. The minimum time is 34. And the maximum time is 82 seconds. So to get the interquartile range, we have interquartile range. It is equal to the upper quartile. Make sure you know how to read this one. I put the 82 because this one is 80, this one is 90. 70, 50. 70 here. So we have 70 minus the lower quartile, which is 48. And if you are going to calculate that one, that would be equal to 22 seconds. Okay, that's the interquartile range for the children. Okay, let us plot this one, letter B. Let's plot first the median. So always choose the median, which is 58. So where is that center? 58, this one is 50. So more or less the 58 somewhere here. So we draw the median here. 58 is here. Alright, that's the median, 58. And then we draw the lower quartile, which is 42. We will form first the box. So we have 42, it is 40. So 42 is more or less here. 42 here. And then the upper quartile is 70, the same. So we have 70 also here. And then we draw the box. So the box is this one. Now let us draw the whisker. So for the minimum is 28. So this one is 30. 28 is more or less here. This is the whisker now. And the other whisker on the other side, the maximum is 75. So this one is 70. Half of this is this one. So here is the other whisker on the other side. Then we connect the whisker to the box here. And then we have the box and whisker plot. So what is the interquartile range here? So you just subtract 70 minus 42, and that would be 28 seconds. Number 13 class, we have a triangle. Inside the circle, and all the vertices of our triangle are on the circumference of our circle, and one of the sides of our triangle is the diameter, because this is O. If for the opposite angle of this diameter is 90 degrees. Yeah, so have a right triangle here. So this one is the hypotenuse AD. We have side CD and side AC. Now we have to find first side AC. How do you find that one? By similar triangles. We have the small triangle here and the big triangle. So we'll do some ratio and proportion. So this is our point of reference. Short divided by long, short divided by the longer side. Or the longer side from here always, not here, not there. So the longer side divided by the shorter side is equal to the longer side divided by the shortest side. So we have that proportion. So from A, let's first have the shorter leg or the shorter side. So you have 21 is to the long one, the AC. Short over long equals. This one is short, so we start with the shorter side, 13.5. Is to the longer side, this is 18. So this one is 18, and this is our equation to solve for side AC. By cross multiplication, multiply this one there, multiply 18 to 21, multiply 13.5 down. So AC there is equal to 21 times 18 over 13.5. Then we multiply 21 times 18. So our AC is equal to 378. That is 21 times 18 over 13.5. And our AC here is equal to 28 centimeters. So that is side AC. In our triangle class, we have already side AC and we have side CD, which is 18 centimeters, and this one is 28 centimeters. We can find now the hypotenuse of our rectangle, which is AD, by Pythagorean theorem. So by Pythagorean theorem, this side, the hypotenuse, because that is the right angle, this one is the hypotenuse. So we have AD, hypotenuse, raised to the second power, because this Pythagorean, is equal to side AC. So we put side AC squared plus side CD squared. CD squared. We solve for AD. Squared. AC is 28. So we have 28 squared plus CD. Where is the CD? 18. So we have 18 squared. So we have 80 squared is equal to 784 428 squared, okay, plus 324 418 squared. Then we add this to 80 squared is equal to 1108 here, and then we take the square root of that one. Square root of 1108 is equal to 33.29 centimeters. But we are required to find the radius. This one is the diameter. So what do? Is we just divide this by 2. So the radius is equal to this one, 33.29 centimeters, and then divide it by 2. And that would give us 16.6 centimeters. That is the radius of our circle. Number 14, we have a f of x is equal to 4x plus 3. G of x is equal to 5x minus 4. F of g of x is 20x plus p. There is another letter there. Find the value of p. So this one means we are going to substitute the 5x minus 4 to the x of f of x. So here we have f g of x is equal to 4 times, we will replace x by g of x, which is 5x minus 4. So we have 5x minus 4 and then plus 3. Then this one is distributive. 4 times 5x is 20x. And then 4 times negative 4 is negative 16. And then we have the 3. Now, when we combine them, so we have 20x. And minus 16 plus 3 is minus 13. So here we have 20x, we have 20x. What is our p? So our p is negative 13. Letter B, h of x. So we have 5x minus 1 over 3. And we are required to find the inverse of the function h of x, h negative 1, inverse. So here, we will replace first this one by y. And then we have this one. So 5x minus 1 over 3. Then we solve x in terms of y. So here we have solve for x. Okay, to solve for x, we cross multiply 3 to y. So we have 3y is equal to 5x minus 1. Transpose 1 plus 1 plus 1. So we have 3y plus 1 on the left is equal to 5x. We remove the 5, so we divide this by 5. We divide also this by 5, so cancel. Therefore, this is our answer. So, here, h inverse of the function h, because this one is x, we will replace that y with x. So, this one is 3x, not y anymore. Okay, return it back to x, and then we have 5, and this is the inverse of the function of h. Number 15, we have a circle here, and point P, R, and Q are points on the circle. So we have point P, point R, and point Q. They are on the circle. AB, this line here, is tangent to the circle at Q. What do you mean by tangent? Tangent means that is a line that intersects our circle at only one point. So at point Q, we have the tangent AB. QR, where's QR? This one, this is a QR, bisects angle PQB. So PQB, this QR, bisects this angle here. What do you mean by bisects? Bisect means to divide into two equal parts. So here, this angle here is also x. So PQR, so let's put here, angle PQR is also equal to x. Reason? Your reason is because QR bisects angle PQB. If QR bisects PQB, then this angle is equal to this angle, because bisect means to divide into two equal parts. X, X. We have an X here. The next one is, we have this one. Angle RPQ or QPR is also equal to that X there, RQB. So we will put here X. So the second reason is angle QPR, okay, or RPQ, to have QPR is equal to X. The reason is this one is the alternate segment theorem. Alternate segment theorem. This one is the alternate segment of BQR, of angle BQR. Okay. Now, in this triangle now, we have two angles which are equal. If we have two equal angles, therefore we have an isosceles triangle. It can't be an equilateral or equiangular triangle because our x is less than 60. So it can't be an equilateral triangle. Therefore, it proves that triangle PQR is an isosceles triangle. Why? Because it has two equal angles.